Good morning and welcome back to another one of my videos. Today, as you can see, we're not in the workshop, we're actually in my living room, and what we're going to attempt today is an electrical repair on a Shark hoover. The hoover had a fault, but fortunately we managed to get it repaired under warranty. But I'm just going to take you through the process of what I did to diagnose the fault. I'm going to repair the old part, so if it breaks again we'll have a spare. So let me show you what's going on. Right, so this is the hoover in question. It's quite a new Shark machine. It's only about 4 months old. It's the NZ801UK. Nice machine, quite good quality. Does what it says on the tin. It's a two-part hoover. You can use it as a normal upright hoover, or you have this pull away section that you can lift off if you want to carry it up the stairs and just use the wand, etc. For other applications or other uses. Right, so the problem we have is that when the motor's running and you tilt the hoover back on the swivels down here, you get two LED lights light up, and then you've got an electric motor in the base, and that powers the twin brushes that are in the bottom. I'll show you those. You've got twin brushes, you've got a soft roller at the front, and then you've got your main brushes at the back, and they are driven by an electric motor in the base there to power everything along. And you've also got an indicator light at the back there that flashes red when the base is blocked up, green for go and all that sort of stuff. And let me show you what it does. Right, so there's going to be a bit of a noise alert here, so turn your volume down if you've got your headphones on. So as you can see, the motor and the pump's running. You've got plenty of suction coming through the hose, but when we tilt this back, what you're supposed to get there is the motor's supposed to start running and then lights come on. But as you can see, nothing is going on. So somewhere in that base there's a fault. So we got onto Shark straight away, and being it's only 4 months old, straight away they sent a replacement, which is this one. So if we just swap that over, which is a quick, all you have to do is lift that away there. Just bear me a sec. Alright, it takes 2 minutes to swap them over. So this is the old one, this is the new one. So when you switch it on, the lights come on, and when you tilt it back, see the motor will power. Now the way this works is a bit strange, because this is detachable. If I just set that down somewhere over there, as you can see, the feed wire, the mains wire, goes into the main pump unit. But to get these rollers moving, these rollers need 240 volts. So what they do is, I don't know if anyone's familiar with the new Pico 4425A with the BNC Plus wiring terminals. This works the same way. It sends the feed up this nozzle, up this tube, into the handle, down, and into the base unit. So I'll show you now where the connectors are. So initially, if we take this off of here, that just detects off of there, and we'll lay that down. We'll put that to one side for a minute. Right, so if we unplug the hose from the main hoover part, it looks like a standard hose, but when you look down inside there, you've got two metal pins, metal connections, and inside the base bit here, you've got two connectors there, which is where it sends the 240. So to trace where the break was before, well, this is before we got on the phone to Sharp for the warranty claim, we traced the feed. So if we switch the hoover on, and if you back probe the two terminals on the back of the hoover, see, you get 240 volts now, 248. Turn that off. So now we know that we've got mains voltage coming out the hoover itself, and that goes into this socket here. So we'll clip that back in. Right, and the next point of call. Right, so the next point of call is in the top of the handle. So the feed comes up this tube, around into the handle, and like a gun, you've got your connections there. So what we'll do is, again, we'll start the machine. Well, back close these, we'll close these. So you can see we've got 247 volts there. So we'll connect that back in. Back into there, that clicks into the wand, and then again at the bottom of the wand you've got the same connectors there again, and again at the bottom of the wand got the 240 volts, so we know we've got power to the bottom of the wand. Now this part here is where it clips into the base unit, and if you can see in the base unit you've got your 3 pins down there, the centre pin being an earth, I would imagine. So what we'll do now, so what I did after that, I should say, is on the back of here you've got another cover that you can take off with these 3 screws. And then there's another wiring block here, and that sends the feed wires down through a little swivel in here and through the join, through the swivel part of the base, and the wire disappears down the side here somewhere, and inside here is a micro switch, but somewhere between here and here, through the swivel, where it obviously moves when you're hoovering, there's a break in the wire because no power reaches the base unit. So what I'm going to do now is to take a resistance check of the new one on those 2 outer terminals and see what we get there. So just bear with me a second. Right, as you can see, or if you can't see, I am touching the outer terminals of the connector, and we have a resistance of 317,000 ohms, kilo ohms, 317 kilo ohms. So if we do the same thing on the old one, just bear with me a second, a bit fiddly to get onto. Right, I'm on the terminals there, and we have open circuit, so there's definitely a break in there somewhere. Right, so just bear me a second, we'll put this one back together. Alright, so once we'd found out what the problem was, we got onto Shark manufacturer, and straight away they identified the problem. It must be quite a common problem because they had one in stock, and straight away they said they'd send a new unit out. And the very next day by DPD we got the new head unit, plugged it in and all was good. So that's good service from them. So now I think what we'll do is we'll take this old one out to the shed, we'll disassemble it, try and find where the broken wire is, and see if we can repair it, because in 4 months time, unless they've done an improvement on the design, chances are that wire, whatever's broken inside, is going to break again. So we'll see if we can mend this one, so we can have a spare. So I'll see you in the shed. Right, so here we are in the garage, in the shed. If I turn this way up here so we can see, this is the unit that I was saying about, where the wire, where the feed comes down into this block here, and there's another connector there. So we'll take that out, and these 3 screws are security Torx, and they are a T20. So we'll get those out. Right, and now those 3 are out, this panel comes off, and this is where the wire comes down from the lance into here. Let me zoom into there for you a bit. So when I measured here on this pin and this pin, we had 240 here, and that disappears through this hinge. There's like a pivot point where this pivots. So that then becomes a pivot point. So I'm assuming that the wire is broken in this part here somewhere. So let's see if we can get into here by taking this bottom plate off. Initially, to clean it, you've got these 3 locking tabs, and then this base plate comes off. So let's get that off. Like that. It's a bit tough, but it just pops off of there, like so. And then this front roller, there's a little tab on the side. You push that forward, and that roller pops out. So we'll get rid of that as well. So that gives us down. Now we need to get this cover off here, or it might well be that the top cover comes off and leaves the base bit. But we've got more Torx screws. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, well, 11 Torx head screws there. So let's get all those out. Right, so we've got all the screws out, but there's nothing moving on the base because the base comes right round as part of the rollers. So I think what's going to happen is, I think this top cover is going to come off, and it's fairly loose. You can see it comes up, but it seems to be held on at the front. So I think what we've got to do is maybe take these little Torx head screws out as well, to see if we can dismantle some more of the front. So these are T10. Let's take these ones out as well. Let's see what we've got on there. I think that's just right. Right, one moment, I think I need 2 hands for this. Be back in a sec. Right, so we've got the cover up a little way, but it seems to be stuck on some tabs, so it might be a case of just flicking some tabs out around the front, because I mean it comes up, it seems to be free under there. Oh, here we go. Oh, here we are. That side's free. Right, I'm going to get 2 hands again, be back in a sec. Right, so there was an extra screw. I don't know if you can see it up there, it was covered in dust and debris from the hoover. But there was another screw in that corner holding that end on. So now, this whole top plate comes off. And inside is all the gubbins. We've got the motor with the drive belt down the side there, driving the pulley. We've got the air tube that comes along the middle. We've got the LEDs at the front here. With a little circuit board with a nice wire nut on there. That's lovely. But this is the that's the micro switch that I was telling you about. I think what happens is, that's it, when you put the hoover into the upright position, when it's all bolted together, this little tab here, where are we, can't see, this little tab there goes down and shuts off this micro switch. So if you watch that, when I put the handle into the upright position, it pushes it down. But this is all flop at the moment because it's not secured down. So we've got to find out where these wires come in, and I can see one wire coming in down the side there. So it goes through that hinge. It must go up the side of the hinge. Well, I can't see you. It goes up here through the hinge. Then it must go up that channel there somewhere and into there. So what we need to do is to dig these wires out, and I see we've got a white and a yellow. The white, the yellow is the earth, so we need a white and a black. Do we have a black wire? Yes, we have a black wire there. There's your black wire. So let's take this white bit of sponge off and see what we got in there. Okay, so off camera I took out the 2 little screws out of here and took this cover off. I thought I might get some more access in there somewhere, but you can't. It's so tight in there. You can see the wire disappears down, and it must go down the side in a channel down inside here, and then it comes out across here and then out in next to this wheel, where you can see the wires just coming out down the side there. And you've got the 3 wires. You've got the white, the yellow and the black coming out. And under that big white spongy bit, you've got these 4 wire nuts. You've got one for the black wire, one for the white wire, and one for the yellow wire. And then there's also one for a main feed brown wire which goes to the motor. But the ones we're worried about is this black one and this white one. The yellow one I think is going to be okay. So what we need to do is test the resistance between the terminal here and the terminal up in the end of there and see which one of these two is broken. So let's get on and do that. Right, so let's set the meter on resistance. We'll check our leads. That's good. Right, so first of all, we will go from the black one to the black one, which is the right hand one. And as you can see, 0.2 ohms, so we've got good continuity on that one. And then we'll go from the white one if I can get my probe in. Right, so on that one we've also got 0.2 ohms. Right, so it gets intriguing, isn't it? Because so the white isn't broken. Right, let's just try the yellow one in the middle. Right, so the yellow one as well is 0.2 ohms. So we don't have a break there. So the fault then must be, let's get the camera, bear with me a second. Right, so we've got no break in the wire between the 3 pins in there and the yellow, the white and the black wire down here, so that's all good. So maybe the trouble is with the micro switch. So that's got a little blue lead on it over to here. Let's see if we can test that. Let's see whether it's got an on and off continuity. It's hard to show you, but I'm on the 2 pins on the blue connector, which is for the micro switch, and in its normal state we've got 0.2 ohms, so that's a good connection there. When I close the switch, it does shut off to infinity, so the switch itself is working. So on to the next stage. Right, so the first thing I found when I've been looking at this circuit board is, let's see if we can get a light on the subject. That item there, this item there, it says F1, so that I would imagine means fuse 1. Now when I check that for continuity across the two, I've got both my probes on there, and we have got open circuit. Now that could be the problem. So let me just go through and see what else I can find, and then I'll be back shortly. Right, so what I did find was that where my black probe is touching on that terminal of that fuse, see we've got open circuit at the moment, but if I touch the the mains terminal in there with that probe, we've now got an open short circuit. So that pin there, that mains terminal there, is directly connected to this side. Where are we? To this side of that fuse. But then again, if I go to that side of the fuse, we've still got open circuit. So that, I believe, is the cause of our issue. A blown fuse right there. So what I've got to try and do now is, it's got some numbers on the back, is to find out what value that fuse is. Oh wow, that was pretty epic. I just a bit of a lightning bolt and a bit of a flash and a bang. I'll show you what I did, just bear with me. Well, I thought my idea was to use this jump cable to bypass the inline fuse, just to see whether it had been like thermally activated because it got too hot. I thought what I'd do is I'd shut the micro switch off, and I'll put a couple of leads onto the connectors down there into the socket in the wall. I thought if I power it up just to see whether the lights come on, just to see whether that is the fuse that's causing the issue. As soon as I switched it on, there was a big bang and a flash, and it all went crackle, and a load of smoke came out of it. And I think it's all unplugged now. But I think what the problem is, the transformer. I think the transformer there has gone. Just shorted out because there was a big flash from that sort of area. I think we can safely say that this is probably dead. So I think what I'll do is I will take the circuit board out and have a look at the underneath. But yeah, it was a pretty big old flash. I should have caught it on camera really, that would have been interesting. But there you go. Right, so this is going to be it for now. Well, I think I'll take the circuit board out and then we'll finish it. So we'll be back in a sec. Right, so I've got the circuit board out. Looking at the circuit board initially, I couldn't see, let's wait for it to focus, I couldn't see anything wrong with it on that side. And when you turn it over, it all looks clean on that side. Where that fuse is, it comes in here. That's the main terminal in. Let me get a pointing device. Right, that's the main. That's one of the main 240 pins in. And then the first place it goes is into this contact here, which is for that thermal fuse, which goes across there, and that's where it's not making contact. But what I did notice is when I was looking at these things, when you look at these wires, you can see all these wires are black, and these wires were all tucked down the back here. So when you look on the same place on the circuit board, because the circuit board was sitting in there like so, if you look down the side, if I can wedge this up somewhere, you see down, you see on the side of that's all black, and under here is all black. And it's all black around here. So either, I don't know what, I don't know what this black unit is here, but whether that's gone, or I mean that's the yellow, that's like a relay next to it. That's got a number on it, if I can focus on that. I'm not sure what that is, GBU 8K, but it looks like it's that's blown. And the sparks, I would imagine, all the sparks shot out of here. That was the general area where it came out of. And as it did that, it burnt all those, marked all those wires which are tucked down behind that slot. So, for the time being, that's going to be it. I'm going to go online and see whether I can find another circuit board, which I doubt I probably can. It'll probably be just part of the unit. But I might take all this white gunk off and see whether I can desolder these. But that I think will be a part 2, because to be honest, I think this is toast. Focus, there you go. I don't think there'll be anything I can do with that. So we'll leave it there, guys. Thanks for watching, and we'll see you in the next one.